in this video we're going to have a look at the structure of peptides. Now peptides are what you get when you join amino acids together. So amino acids join together in a condensation reaction, and when they join together, what you'll see is that the Q group from one amino acid is going to join to the amine group of another with loss of water. And we're joining by what's called a peptide link or a peptide bond. Now, if we were talking about regular organic chemicals that weren't amino acids, this would be called an amide bond, but in the specific example where it joins amino acids, it's called a peptide bond. So they're formed by condensation reactions. So let's have a look. We have a couple of amines. I'm going to draw it out as if I had a dipeptide structure here. We're going to take our variable R group there, and we're going to have a Q group here, like that. And then we're going to have a second amino acid with a different R group, dash, and the Q group. If we put those two together, we could make a dipeptide. So this structure is just going to be a dipeptide, two joined together. If I was making a protein, there'd be many, many more of these. What we're going to do is we're going to eliminate, in our condensation reaction, that water molecule is going to come out, and we're going to join those two sections together. So we're going to have a H with an N, and a H, and a C, which has our R group, and a hydrogen, and then a C with a double bond O. And we're going to join to our nitrogen, which has one hydrogen, and then a C with a different R group, and a hydrogen, and then our carboxylic acid group at the end. This would be a dipeptide. Got two amino acids in it, joined by one peptide link. And remember that we've lost some water, so you could put plus H2O somewhere if you can squeeze it in. So water is removed, and what remains of each amino acid is called an amino acid residue. So what remains of each amino acid? So if I was to look at this, this would be a residue, and then this would be a residue without the water. Peptides containing two amino acid residues are called dipeptides. That's what we've drawn up there, a dipeptide. Tripeptides would contain three amino acids. And these polypeptides are actually going to be considered as condensation polymers, but made of amino acids rather than repeating units of the same chemicals. So if you've got two different amino acids, they could join together in two different ways, because putting something on the left will lead to a different product than if you put it on the right, because the standard way to draw these is with the amine group on the left and the carboxylic acid group on the right. So whichever one's on the left is going to lose the OH from its carboxylic acid group, but whichever one's on the right of my dipeptide is only going to lose the hydrogen from the amine group. So swapping their position actually makes a slightly different product. So let's have a go at doing that. If we know that in alanine, our R group is actually a CH3, these are on your data sheet, and in glycine our R group is a H, we could think about the two different ways round we could make this dipeptide. So pause the video and take a couple of minutes and try to draw your two different dipeptides. So there you go. I've drawn my two different dipeptides, and I've used different colours to help you spot what's going on. So I've drawn alanine in black in both structures, and you can see that on the left hand dipeptide I've drawn, alanine's lost the OH, But on the right hand side dipeptide, alanine has lost the H. And in red I've drawn my peptide link, or bond. That's my peptide bond there, that links my two amino acid residues. So in this example we've got 2 moles of leucine and 1 mole of serine. So again we can use our data sheet, but leucine is where our R group goes CH2, CH bracket CH3 twice, and serine is where our R group goes CH2OH. You can actually make 3 tripeptides. So have a go and see if you can draw out the 3 different tripeptides you would get if you have 2 leucines and only 1 serine. Okay, so my first structure I've gone leucine, leucine, serine, and you can see that this time I put the R group down at the bottom just because I had a bit more space. It doesn't matter as long as it's coming off that middle carbon, and you can see how I've connected those 3 together. And in this second structure I've gone leucine, serine, leucine. So there would be a third structure, which I've run out of space, so I will do it, but I'm going to rub off my top structure that would go serine, leucine, leucine. So I'm just going to rub off my top structure and then you can see if you've got the same. And there you go, for my final structure I've gone serine, leucine, leucine. So 3 different dipeptides possible, tripeptides even possible there. So when we formed this tripeptide, how many water molecules were produced when 1 tripeptide was formed? Think about how many peptide bonds you formed. So we formed 2 peptide bonds, so 2 moles of water. Make sure you can draw dipeptides and tripeptides and think about different arrangements.